Again, welcome to DSRT 734 class. In these lectures, we shall go through graphs in statistics. Our main objective is to graph quantitative data using stem and leaf plots and dot plots. Also graph qualitative data using pie charts and Pareto charts. We should also graph a paired data set using scatter plots and time series chart. Now, a paired data set means our data set with two variables. So scatter plots will make it possible for us to see the relationship between two variables. Either one increase, the other one will decrease, or vice versa. Also, a time series chart is also a two variables, but this time our horizontal axis will be time. So, for example, a time series chart can be the stock price of a company. We know each time the stock price of a company can change. So we can find out the pattern of a stock price of a company for the past 2 months. And this chart will be a time series chart. So we start with the stem and leaf plot. We said each number is separated into stem and leaf. Normally, for example, we are given a data set 21, 25, 25, 26, 27, up to 45. Now, if we want to plot the stem and leaf plot, the first thing we have to look for is the leading digit. Now, here, since all the values are 2 digits, we can use the leading digit as our stem, and the last digit will be our leaf. So when we look at the data set here, we have the lowest value is 21, the highest value is 45. So we can have a stem to be 2, 3, 4. 2, 3, 4. Then we have 1, 5, 5, 6, 7, 8, which will be on the 2. So 1 here means we have 21, we have 25, another 25, we have 225. So again, the stem will be the leading digit, and the leaves are the last digits. In this case, we have 2 digits. So for example, we have 3 and the leaves are 0, 6, 6, which means we have 30, 36, and another 36. So when we look at our data, we can see we have 30, 36, and 36. Then in the 4, we have only 45. So here we say the stem and leaf plot is almost similar to histogram, but it still contains the original data values. So here we can see the original data values. When I look at this stem and leaf plot, I can say, okay, 22, so 21, 25, 25, 26, 27, 28. Now let's see another example. Here they say we should construct a stem and leaf plot, and the following values is given to us. So these are a lot of values. So the best way to do this is to use a technology, either a computer application or sometimes a advanced calculator like TI-89, 83 can work. So here they say the following are numbers of text messages sent last month by a cellular phone users on one floor of a college dormitory. Display the data in a stem and leaf plot. Now we can see that most of the values are 3 digits. So we first of all put the values in ascending order. It's up to us. We can put it in ascending order, or we can just look at the values, the lowest and the highest. So we saw that the lowest value is 78. The highest value is 159. So now if we decided to use 1 digit, the first digit, as a stem and the last digit as the leaf. Now, if it's 3 digits, then the first 2 digits will be the stem and the last digit will be the leaf, because we can't use only 1 digit. Otherwise, 7 will be 78, then 1 and 59, it will be mean 1 is 10th. So the best way to do this, as we said, for instance, we say 78 should be 7 should be the stem, 8 should be the leaf. Then 159, 15 should be the stem, 9 should be the leaf. And this is the best to solve it, to plot this graph, because the lowest is 78, the highest is 159. So here we can count that the least stem will be 7 to 15. And also for each data entry, we are going to list the leaf to the right of each stem. So since most of the digits are 3, the leaf will be 2 digits. So here we can see we have 7 and 8 because we have only 78. But we don't have no value in 80s and 90s, so it's left blank. There's no leaf. But in hundreds, we have 105, we have 105, 108, 109, 109, 109. Then we have 11, which means 116, 114. Again, the first 2 digits are the stem, and the last digit is the leaf. Now we can plot this in an ordered also. So here we can see we have 58999, but here we have 642. We put it in order, we get 22234, which means the lowest values come first before the highest value. So this is called the ordered stem and leaf plot, and this is unordered stem and leaf plot. Now with the stem and leaf, as we said, the whole concept is that we saw the first example, most of the digits, all the digits are 2. So the first digit will be used as a stem and the next digit as a leaf. But in our second example now, most of the digits are 3 digits, or most of the values are 3 digits. So we use the first 2 digits as a stem and then the last digit as a leaf. So now let's go to the dot plot. So the concept of dot plot is that first we are going to draw a vertical line. Then this vertical line should be in a scale. So here we have our scale from 20 to 45, because the values we have, the lowest is 21 and the highest is 45. So we make our scale a vertical line with a scale 20 to 45. Then each value we are going to plot it. That's why it's called dot plot. We are going to have a dot. So for example, we have 121. So there's 21, we have 1 dot. There is no 20, so there is no dot. Next value is 25. We have 225, so we have 2 dots. Under 25, 2 dots. 26 is 1. The rest of the values are 1, 26, 27, 28, 30. They are ones. But 36 is 2, 36, 36. So we have on 36, we have 2 dots. Same thing, if 36 is 5, then we are going to have 5 dots vertically. So dot plot can show us, again, the pattern of the data, which is almost similar to stem and leaf plot or histogram also, to see the pattern of most. So here we can see that most of the values is only 2, which is 25 and 36. The rest, again, are 1 value each. So we have example here. They say we should use a dot plot to organize our text messaging data. So again, first thing we look at the lowest value is 70, the highest value is 160. So I'm going to plot a vertical line, which will start from 70 to 160. Then we have our first value should be somewhere around 78 or 79. And let's see, the value should be somewhere here, 78. So we have 178. Then we don't have any value up to 105. We have 1. Then on 110, we have 3. 109, we have 1. So we plot all the dots under each value. So for example, we have 160 and 159, which is also 1. So we say from the dot plot, you can see that most values will cross that between 105 to, again, 148. And the value that occurs the most is 126, which is right here after 125. You can also see that 78 is unusual because 78 is way far away from the rest. So we may say this is as outline data, unusual comparing to the rest of the values. Next is how to graph a pie chart. A pie chart normally is good for qualitative data. So for example, a percentage of something or the counting of something. So a circle is divided into sectors that will represent the categories. Now, the area of each sector is the proportion to the frequency of each category. So we know a circle may be 360. And if we have 36 by 360, will be the part of it, maybe 10%, 20%, etc. So let's see an example here. We can see that our data set here, again, is a qualitative data because we have the vehicle type and the kill. So vehicle type is more or less like a label. And then the kill section is the counting. So we have cars, we have 18,440. Trucks are 13,778. Motorcycles are 4,553. And others are 820. So we can look at the percentage of each year. We will say the total will be the whole circle, which the total year is 37,594. So this is more or less like we are having the frequency table, which we cover in our previous lectures. So we have the labels for cars, trucks, motorcycle. Then we're going to find the relative frequency for each category. So a car's relative frequency will be 18,440 divided by 37,594. And that gives us 0.49. Trucks will be 13,778 divided by 37,594. And that gives us 0.37. Motorcycles will be 4,553 divided by 37,594. And the other will be 823 divided by 37,594. Now, if we had all these values, we should get to 1. When we had all the relative frequency to give us 1. So let's see an example here. They say we should construct the pie chart using the central angle that corresponds to each category. Now remember a circle, the total angle is 360. Based on our question, we have 0.49. So we are going to say 360 times 0.49. That will give us 176 degrees. Then we do the same thing for the rest. For trucks, it's 0.37. So 360 degrees times 0.37. Then with motorcycles, it's 0.12. So the central angle will be 360 degrees times 0.12. Then other is 0.02. So we get 360 degrees times 0.02. Now, if we add all the degrees here, it also should give us 360. Because why we are using 360? Because the central angle of a full circle, of a circle, is 360 degrees. Of a line is 180. So now we come and plot. So we can see that cars is 49% because it's 0.49. Trucks, 37% because it's 0.37. And then motorcycle is 0.12, 12%. And then others is 2%. The total again will give us 100% or 360 degrees. The next is the Pareto chart. A Pareto chart is more or less a column chart, which is a bar chart, almost close to histogram. Histogram, there's no space between the bars, but with column chart, there is a space, or Pareto chart. So here we say Pareto chart is a vertical bar graph in which the height of each bar represents the frequency or relative frequency. So in Excel, we call Pareto chart as again a bar chart, concept of a column chart also. So the bars are positioned in order of decreasing height with the tallest bar position at the left. So now this is the difference between column chart and also a Pareto. A Pareto chart, always the tallest bar will come first. But with column chart, it doesn't matter. We can have any category maybe we have the other category first, so other will come first before cars or trucks. But with Pareto chart, we want the category with the highest frequency should come first, which will be the tallest bar. So we have an example here. They say in recent year, the retail industry lost $41 million in inventory shrinkage. Inventory shrinkage is the loss of inventory through breakage or peeverage, shoplifting, and so on. Now, the causes of the inventory shrinkage are administrative error. Administrative error is 7.8 million. Then employee theft is 15.6 million. Shoplifting is 14.7 million. And also the vendor fraud is 2.9 million. Use the Pareto chart to organize this data. And again, this data came from National Retail Federation Center for Retail Education, University of Florida. So remember the Pareto chart, we want the tallest or the category with the highest frequency should come first. So those would be with the highest value or the maximum, for example, 50.7 may come first before 14.7. We know the total is 41.0. So to find the relative frequency, to be 15.6 divided by 41.0. And that will be the category for employee theft. So this is our administrative error, employee theft, shoplifting, vendor fraud. So we can see that with the Pareto chart, employee theft comes first because that is the highest loss. Then next will be the shoplifting, 14.7. Then the vendor will be last, fraud, vendor fraud, the lowest. Administrative error is third. Now, if we like, we can also come up with the relative frequency first. If we want to, again, plot, we can also have the pie plot and the pie chart for this. In the pie chart, we can come up with the relative frequency, then the central angle also. Because again, this is also a kind of a label. So we can use the Pareto chart for qualitative data or pie chart also for qualitative data. Now, next is graphing a paired data set. So we can see the diagram here. Here, we want to find out if there's a relationship between a data set that have two variables, X and Y. In our previous example, each data set have only one variable. For example, this example is only one variable, the total theft for each category. Now here, based on this graph here, we can see that, oh, okay, when X increase, Y decrease. So the relationship between X and Y is a decreasing relationship. Most of the patterns is going down as S is increasing. So here we say each entry in one data set will correspond to one entry in a second data set. So graphing using a scatter plot first, we need to get the other pairs. So the other pairs are graphed as points in the coordinate plane. What we mean by other pairs is that each point, this is a two-dimension. So each point will be a value of X and Y. So let's say, for example, when X is 1, Y is 10, that's this point. When S is maybe 1.2 and Y is 8, that's this point. So that's why it's called the ordered pairs are graphed as points in the coordinate plane because each point have two coordinates, the S value first and the Y. And we use the scatter plot to show the relationship between the two quantitative variables. So the relationship between Y and X here, we can see that when S increase, Y will decrease based on the pattern most of the time. So let's see an example here. Here we have a British statistician, Ronald Fisher, introduced a famous data set called the Fisher-Harris data set. This data set describes various physical characteristics such as the patella length, patella width in millimeters for 3 species of Harris. The pattern length forms the first data set, and the pattern width forms the second data set. So this source came from, again, Fisher, R.A. or Ronald Fisher, 1936 article research. So as the pattern length increases, what tends to happen to the pattern width? We can see also that the pattern width also increases because the pattern length is the horizontal. As it's increasing, we can see that the pattern width also is going up because they are going towards the right. So here we say each point in the scatter plot represents the pattern length and pattern width. As we said, this is two-dimension. Each point represents, for example, this point here says that when S is 30, which will be our pattern length, the horizontal, we may say the Y, which is the pattern width, is 11. So this point have two values, 30 for pattern length, 11 for pattern width. Now, based on the pattern, we can see that it's going up as S pattern length increase, pattern width is increase also because it's going up. So the relationship between these two, we say from the scatter plot, we can see that as the pattern length increase, the pattern width also tend to increase. So the relationship is called the increasing relationship between these two variables, which is the pattern length and also the pattern width. Now, the next is the time series. Time series is almost the same as scatter plot, or in Excel, we may say a line chart. So for example, here we can see we have two variables again, but this time, always the horizontal x-axis will be time. So that's why it's called time series. The data is based on time. So based on changes of time, the quantitative data, it can be a price or anything will change. A good example is always the stock price. Stock price changes with time. So here we say the data set is composed of quantitative entries. Example, as we said, a stock price is quantitative data at regular intervals over a period of time. So if I have a stock price of a company for 10 years or 1 year, different prices each month or each day even, we can plot it here. Then we see the pattern. So the amount of precipitation measured each day for 1 month. This example. Now we're going to use the time series chart to graph it. Here is based on what? Time. The time is every month. The amount of precipitation measures each day for 1 month. So if you have 10 measurements, it means for 10 months. And we may see different measurements for each month. So this is the data given to us. The table lists are the number of cellular telephone subscribers in millions. So in 1995, we have 33.8 million subscribers, telephone subscribers. By 2005, we have 207.9 million. So we want to construct a time series. Why is it a time series? Because the year is time. And based on this, let the horizontal axis represent the years. Always the horizontal axis will be the time. Then let the vertical axis represent the number of subscribers in millions. We plot each point. So my first point will be when my horizontal axis for year is 1995. What is the value of the subscribers? It's 33.8. So that's 1 point. 1996 is 44.8 million, 2 points. Keep going. So we plot the graph and we can see that we have increasing order. As the years increase, the number of subscribers also increase. And we can see from the data, each year it increases. So this graph shows that the number of subscribers has been increasing since 1995, with greater increases recently. So that will be the conclusion of these lectures. So again, in these lectures, we cover the basic graphs that we can use in statistics. And what is a graph? Basically, a graph is a visual representation of data. Normally, when you have a picture, you can understand it and see the pattern faster than if you are going through values. So here we have a number of subscribers of a telephone for 20 years. We're going through the values, we may see whether it's increasing or decreasing. But if we can plot the time series graph, we can easily see the pattern straightforward as we saw it here. Instead of going through all the list of, especially imagine we have 100 years, 200 years. We don't want to go through all the list. If we plot the time series graph, we can see the pattern straightforward. So again, wish everybody the best and thank you.